understand the chemistry of fireworks, we need to understand what's called pyrotechnics, which is the science of how chemical reactions produce heat, light, gas, smoke, and sound. We know that if we mix oxygen and hydrogen atoms with enough activation energy, we can break their polar covalent bonds. The atoms rearrange themselves to make water, and not just water, but energy in the form of a bang. Bangs form fireworks using gunpowder. A good gunpowder is one that reacts in the fastest way possible. The earliest known formula for gunpowder is from a Chinese military manuscript, which says a gunpowder using specifically 75% potassium nitrate, 15% charcoal, and 10% sulfur will react in the fastest way possible. If you make gunpowder manually using this formula, lay it down in a straight line, and light up one end, then it'll take about a couple seconds or so to burn completely to the other end. This is because your handmade gunpowder has very large particles on an atomic scale. This means that there is plenty of space between particles, so size matters in relation to this. Today, gunpowder is made by machines that grind up the particles really well. There's something special about charcoal. This picture using an electron microscope shows how porous and spacious charcoal really is. When the machine is grinding away, it's actually shoving these holes with potassium nitrate and sulfur, which make it burn faster than the handmade one. Okay, so we know that at lower temperatures, molecules move slower, right? And as temperature increases, molecules move faster and collide with each other. So with this being said, if we increase the density, there will be more particle collisions. So, in summary here, rate of reaction increases with increasing temperature and increasing density. When gunpowder is burning, it releases hot gases that are expanding against the atmosphere. As they expand, temperature falls and density falls, causing the reaction rate to actually slow. If we put the gunpowder in a very small container and burn it, the hot gas produced cannot escape. Thus, the temperature and density cannot fall, and the rate of reaction will increase. Since the hot gas is trapped, the reaction will continue to increase. This concept is called thermal runaway. To produce better bangs, there would need to be a lot of gunpowder and very strong containers. Therefore, using gunpowder and confining it is not really the best option. So instead, we use something called flash powder, which is composed of potassium perchlorate and aluminum powder. It burns quickly and when confined produces a loud noise. It's widely used in salutes, cherry bombs, M80s, and was once used as flashes for photography. Today, professional fireworks utilize aerial shells for those really big fireworks you see on 4th of July. But how do they work? Here is a cross-section of an aerial shell. We ignite the fuse, which burns the flash powder. It then acts as a lift charge and fires the shell into the air from the mortar. Simultaneously, it ignites the time fuse. After a few seconds, the burst powder is ignited, producing those beautiful colors you see in the sky. I hope you all learned something today and enjoyed this video and learned how fireworks work and the chemistry of it. Thank you.